Okay, so in the Wittig, what we have is again a nucleophile. What type of nucleophile is this? It's a carbon, guys. What kind of nucleophile do we have? We have a carbon nucleophile. Okay, this nucleophile is made from triphenylphosphine. Okay, so we have these three things. Yes. This is a Lewis acid structure for triphenylphosphine. I'm already in a weird state of mind. I don't want to hear about it. So, triphenylphosphine, I have to make the Wittig. And what am I going to react that with? I'm going to react this with an alkyl halide. Okay. So let's say this is the alkyl halide I use. Now you've never seen this reaction, and I hope that I have explained enough in Organic 1 and 2. Of course, if you didn't take Organic 1 with me, then you might not know, but to have explained enough that you can tell me what the product here is. What's the product?
CH2P, CH2P with the phenols, 3 phenols.
Excuse me?
It's going to be the peak bonded to the CH3, the bromine.
Here's electrons, yes?
Yeah.
And electrons do what on alkyl halides?
Attack.
Either substitution or elimination. If you guys don't understand this yet, you should be... I don't want to say it because, you know, it's public knowledge. So, nucleophilic attack of what type? No elimination. Nucleophilic substitution. This SN1? Crazy, it's SN1. This is SN2 because this is a primary alkyl halide. It's not a primary alkyl halide, that's a methyl alkyl halide. So this is what type of reaction? SN2. Shame on you if you don't know. Okay? So shame on everybody, man. Most of it. Nucleophilic attack, and what are you going to get? This is what you are going to get. Are you not?
Yep.
Yes or no?
With the P positive phosphorus, right?
Okay. Now we can do, let's do formal charge, yes? Formal charge of the phosphorus over here, what is it? You calculate the formal charge of things.
Finger test.
Finger test.
Oh, that's neutral.
It's true, it is a finger test. Let's do it, okay? Let's do the finger. Apparently you guys like it that way. So, phosphorus in what group? It's in 5, yes? Below the nitrogen. So, 5 is the number of valence electrons minus the finger, yes? 1, 2, 3, 4, 5.
It's neutral.
That's 0.
Yeah.
Okay, very good. And here is 5 minus 1,
4.
2, 3, 4. What is it?
Positive 1.
Positive. Just like nitrogen, yes?
Yep.
What the problem here is? Okay. The problem is me. Damn. And then what we add to this is butyllithium. Okay. And butyllithium, do you know what butyllithium is? It's beauty. You don't know that girl, Beauty? It's a girl's name. It's could be called N-butyllithium, okay? Let's draw it. 1, 2, 3, 4. That's butyl, yes?
Yep.
And butyllithium, look like this. Do you agree?
Yes.
It reacts like a base. How strong of a base is this? What is the pKa, more or less, of a carbon-hydrogen bond? Outstanding. By the way, I'm gonna give you assigned seats the day of the test, okay? I'm gonna assign your seat the day of the test. I'm going to change your seats where you are sitting right now. So, butyllithium is a base, yes? It is a very strong base. So what is it going to do if you add a base to this? It is going to pull a proton.
off.
It's
Yeah.
going to pull a proton from here. Now, this is a carbon-hydrogen bond too, yes? So, but the pKa is not the same because of this phosphorus there. Okay? So what's going to happen is, one of the hydrogens is going to get pulled off, and now this carbon is going to have how many hydrogens?
2.
2 hydrogens and
A lone
a
pair. And it's going to be negative.
This is pH, pH, and pH. This is a negative charge, this is a positive charge. Okay, yes or no? Now by resonance structure, this is what you form. By resonance structure, I can do this, yes?
Yeah.
And what that is going to give us is yes?
Yep.
Formal charge on phosphorus is?
Neutral.
Formal charge on phosphorus is neutral. 5 minus 1, 2, 3, 4, 5 is neutral. Formal charge on carbon is?
Neutral.
Yet, it acts like this, yes?
Uh-huh.
It is a nucleophile. This is called an ylide. Phosphorus ylide. So, you might see this on the test. I may write it like this, but you have to know that this acts like what? Like a negative charge here on this carbon. And negative charges do what on carbonyls?
Attack.
They attack it. So let's say we have something like this. And then I add this. Now conditions for this are acidic or basic conditions.
Basic.
How do you know they're basic?
It's a nucleophile.
Because if it's a
Nucleophile.
nucleophile, guys, with a carbon with a minus charge, you cannot add an acid to this because you will kill. Okay? You cannot add an acid to this of any sort. So this is under basic conditions of the attack. Is this going to be ever protonated? No, this is not going to be protonated because there is nothing to protonate it with. So the product of a Wittig, is what we are calling it, will be this group you see here. Is a double bond
With a carbon.
to this carbon.
Yeah.
Is the group that will go here
Yeah.
instead of the oxygen. Okay? So this is a what? What is this? A CH2, yes? So the product will be a CH2 here.
Yep.
Yes or no? The Wittig looks weird, okay? What happened to the phosphorus? I have no idea. Why do you want to know?
I took care of it.
What I care about is called the organic product, okay? The phosphorus is like this now.
The oxygen. Double bonded to the oxygen.
That's what that is, okay? Now in my class, maybe in another class, the professor cares about this very much. It is important, okay? But in my class, if you know this, you get no credit. You know this, you know nothing. This is what I want you to know, okay?
Yeah.
This, you can deal with it later. Okay, that's what's gonna happen. Yes or no? Now, during this, what did we do here? This is an SN2, and it has SN2 related problems. Does it not?
For
example, can I use here tertiary alkyl halide?
No,
Why
not for
can I use
SN2, of course
tertiary
not.
alkyl halide? Because this is going to be
SN1.
SN2. And because of SN2,
can't use
this is
tertiary
limited to
to
primary,
secondary.
secondary alkyl halides. Yes? Hello? All right. How do I make that? Write it down. Find out how you make it. I want you to make it using Wittig, okay?
Wittig.
Don't tell me you are going to have some other type of reaction. You don't know?
I'm trying.
Pitbull. What do you have no idea?
Being honest.
Okay, so the Wittig does a carbon-carbon
Carbon
double
double
bond
bond.
between two carbons, yes?
Uh-huh.
Yes, carbon-carbon double bond. So this came from a Wittig, yes?
Yeah.
So I will cut this, and one of them is going to be a
keto.
carbonyl,
Carbonyl. Yeah.
and the other one is going to be the Ylide. Yes or no?
Uh-huh.
I got two choices. I can make the bottom a carbonyl. Yes or no?
Yeah.
And the other one the Ylide. Or I can make the top the carbonyl, which would be, you agree, yes or no? You see it here, hydrogen here. And the bottom the Ylide. If I make this the Ylide the carbonyl on the bottom, it will be plus what? This is the Wittig here. How many carbons do you see? Two carbons. One here and one there, yes?
Yeah.
So this would look like what? What do you think? Will be a carbon.
Uh-huh.
Is this going to have the charge here at the end? Let's say. It needs to be a double bond between what and what?
Carbon and
Between
carbon.
the phosphorus
Phosphorus and the
and
carbon.
something else, okay?
Yeah.
Well, that's not gonna work. It needs to be a minus somewhere. So which one of the protons do I take off? Do I take this one off?
No.
No, I don't take this one off. This is not resonance stabilized by the phosphorus. I take this one out. So the negative charge would be here. Yes or no?
Mm-hmm.
No?
Why does that come from the CH2?
Because the CH3 is not resonance stabilized by the phosphorus. You make a negative charge here, it's not stabilized by anything. You make it here, and it will make a double bond with the phosphorus. So the acidic proton, from whatever chain you use, is on the carbon next to the phosphorus, is where you are going to make the negative charge. That's a take-home message. Did you get it or no? No, I understand. It's not easy, okay? That's all right.
Why did you say that it's better to make that the carbonyl instead of the one that we do here?
Wait, we're not done. I just made the Ylide, yes? So the Ylide would look like what? If I make a double bond here, it'll look like this, yes? Yes? This carbon-carbon double bond, what is it going to have? It's going to have a hydrogen. What else? It's going to have a CH3. This is what's put here.
Yeah.
You see it?
Uh-huh.
Double bond. There's a double bond. This has a CH3 and a hydrogen. This has a CH3 and a hydrogen. That is an Ylide was used to react with this if I made that a carbonyl. if I make that one up there at carbonyl, what is the Wittig going to be? Let's make it easier, okay? You want to make it easy? We draw this here again. Yes? And write the phosphorus here. Did you like it this way better?
Yes.
And you learn it both ways because I didn't spend the time because I didn't want you to know. So, which of those two is a better route to get to here? These two or these two?
The bottom two.
Okay.
Because the top
The bottom
is
is more reactive.
is more-
I mean, not more reactive. The bottom
Because
is
the
one we
top
are
is
going to use
secondary.
with white.
and the bottom is primary, right?
That's right. It is because this came from a
Primary.
primary alkyl halide.
Yeah.
This came from this alkyl halide. This came from this alkyl halide. From that alkyl halide. While this came from what alkyl halide?
The
This came
secondary.
from this alkyl halide.
Yeah, the double. Okay.
This is secondary.
Uh-huh.
You want to choose one that is primary. Okay, tertiary does not work at all. Yes? You want to do another one? It's exciting, isn't it?
It's very confusing.
I told you, you guys should be scared.
So next week already? So I know I was gonna have to digest this thing.
You should have been digesting it already. a long
Yeah,
time
I
ago.
know this.
No, that's okay. You'll have a few days to digest this one before you gotta digest some other stuff. So let's say let's call it N-butyllithium, okay? This is gonna be so much fun. When we have NMR, I'm gonna give you the NMR for those. A, B, and C. You know what NMR is? Nuclear magnetic resonance. MRI. You ever gone into an MRI? Have you ever seen one? So what the deal is? What's A? That's why you're so quiet.
Is that PHP with the 1, 2, 3, 4 carbons added?
We draw the same business, 1, 2, 3, 4.
4, yeah. With
1,
the
2,
PH3
3,
P.
4.
Uh-huh.
And then
The P with the PH3. Uh-huh.
very good. That one's positive.
Yeah.
Yes or no?
Yep.
Because it is positive, this is more acidic than it would normally be if that phosphorus wasn't there. So we add a base to it, and what does the base do? Pull this
Pull
proton off.
proton
I'm
off,
going to
right?
redraw it again. Yes?
Uh-huh.
Negative charge right here. Yes or no?
Yeah.
Of course, that is going to do resonance
Resonance
structure with
structure.
that, and now it is going to look like this. Let's say
Yep. With the P.
You agree?
Yes.
And now I'm going to react it with this benzaldehyde. What are you going to get?
Benzaldehyde with one.
Then that
The
carbon with the.
that without the phosphorus. Yep.
Carbon here, yes?
Yeah.
There's a carbon there.
Yeah. One.
There's a carbon there.
One.
And then double bond.
Uh-huh.
And then what that is?
1, 2, 3.
How many? 1, 2, 3, 4.
1,
1, 2, 3, 4. Is that it?
Yep.
This had a hydrogen here.
Very nice.
We can have cis trans. Do you want to get into cis trans?
So they're just making alkenes.
Hmm?
They're just used to make an alkene.
Alkenes, yes. Yeah.
I'm looking at the top. I don't see how it's the top right here. This right here. I don't see how it's happening to be the result of that.
Huh?
Like the top one, you have the oxygen and you have the phosphorus. And how in the world do you have a carbon here that's attached to another carbon? That's what I'm
Double bond, yes.
Right.
Carbon, this carbon is that one.
Okay.
And this carbon is that one.
Okay.
Yeah, it takes time. Okay, it takes time. So you like this one, you want to do another one, right? Let's do another one. And everybody has increasing blood pressure today. Galindo, what do you think? Guys, please don't look at me. The answer is not in my face. Please write something down. If you don't, you tell me where that came from. Make it from a Wittig, the same thing we did before. Just one reaction, Wittig, yes? If you don't know what to write, write your boyfriend's name down a few times so you fake it. I think you are doing it. Because I am looking around to see who's doing it. And I'm judging you. It's not good to judge, right? That's my job, to judge you. Only chemistry, though. I'm your chemistry judge. Karen, what the deal is?
today? Are you not recording?
No, we're not recording today.
Yes.
This camera, man.
Oh, yeah. Scared for a second.
I gotta watch this video like 3 times at least.
What are you guys going to do? The next class is not being recorded.
Why not?
Not mine. I mean, like, next advanced organic chemistry.
I'll be calling you.
Yeah.
I don't know anything about advanced organic.
Okay. Yeah, sure.
You guys are on your own. Okay, guys, where did it come from? Where can we cut this?
Right in the middle?
We're gonna cut it at the double bond, right here. If you don't know this yet,
Okay. In the middle.
I'm going to cut it there. And you are either going to make this a carbonyl or that a carbonyl. Yes or no?
Yeah.
So, I am going to redraw the same business, yes? Look, that, the double bond was there, yes?
Yeah.
And I put an oxygen here.
Uh-huh. Ketone.
Yes? That's
Ketone.
okay.
Yeah.
And then if I cut it in the other side, what do?
You just got a methyl, right?
Look,
A methyl with a
there was a
double bond.
carbon,
Yeah, with a double bond. Yeah, double bond.
double bond there.
Uh-huh.
Of course, that would have been an aldehyde. Yes or no?
Yeah,
That's what you did?
yeah.
That's what I
You thought about it.
understand.
You thought about this.
Up to here, that's it.
So
Okay.
far, so good.
Okay.
Wait, why do you make an aldehyde not leave it as a methyl?
Now leave it as a what?
Just a methyl.
Because it's not a methyl, Sophia. It is a carbonyl.
Oh, you're cutting it down the middle, you're not just putting the double bond on
The
it.
carbon, the oxygen is here, yes? And that has a hydrogen on it. Yes or no?
Yeah,
Okay. What do I need here for the Wittig to react with this? You go here
yeah.
and you draw the same thing, yes?
Uh-huh.
Double bond. Like this. Is that good?
Where are you drawing that? You drew that from there, right?
I'm drawing that from here.
Okay, that's the other part.
I put a oxygen at the end of this,
Yeah, I got it.
and what else do I do? How many carbons are in all of this? How many carbons between this ring and this ring?
Three.
Guys, how many carbons do you see in between the two rings? One carbon. One carbon, yes? These two rings.
Counting the rings.
Not counting the rings, no. How many carbons in between the rings? Ring here, ring there, how many carbons in between?
Okay.
One. Okay, so it needs to have this big, only needs to have one before the ring, yes? So there is a double bond, yes or no? On one side, I put an oxygen, and on the other side, I put a phosphorus. That's what you kept saying to me, huh? Okay, good for you.
It's a clean up to you.
Oh, it's not, it's a P, not PH, huh?
pH.
You guys even catching my mistakes, you're so amazing, and I wrote it again. It's called attention deficit. Okay, you try to do it for the other.
The one at the bottom?
What do I do?
Same.
Okay, so I put the double bond here in this case, yes?
Yeah.
And now I make this side here, the carbonyl. So I'm going to redraw this double bond again. You see it? And at the end, I'm going to put phosphorus. Yeah, it happens to me all the time. It happens to you on the test
Have
too?
mercy.
I know. That's why I take points off. More than likely, if you write pH here on the test, I won't take off points. Because I make the same mistake all the time, yes? So which one of these two is the best way?
The top.
Which one is the best way?
The top.
What do you look at? Do you look at this?
No.
No. You don't look at this. You look at the Ylide is what you look at. When you look at it, you need this to be the what?
Primary one.
It needs to be primary or secondary, yes?
Yep.
And this one here is secondary, while this one here was,
Primary.
I mean, this one here is secondary,
Uh-huh.
yes? Secondary here, while this one was primary.
Primary.
Okay? So we choose whatever was primary. So this is the best way of doing it.
Do we have to write both on the test and then choose which one?
No, you don't have to write both on the test. I mean, if you write both on the test, I see what you did. If you write just the one on the test, I think you might have looked at your neighbor. Okay? So when you look at this here, without doing anything, yes?
Uh-huh.
Let's say we don't want to go through both of them. Let's say we want to do it from here, we want to decide now. We got to break some, and where is the Ylide coming from? Is the Ylide coming from here or from there? You look at the double bond,
Yeah.
whichever one has less substitutions, this side of the double bond has less substitutions. This was the Ylide. So this side will be the Ylide. Just change that and put a carbonyl there, make the other the Ylide.
Okay.
You want to try another one?
Yeah, let's do another one. But that makes sense now. How you,
Yeah.
your last explanation.
We got to do it slowly. If I show you that first, then you don't understand the rest of it. That's it. Sometimes the simplest stuff is the hardest. Okay, you make that starting from triphenylphosphine. What time is this class over?
What time is it?
It's 11:05, yes?
Dang, already?
So what do? We gotta clip the double bond, yes?
Yeah.
There it is. Which side has less substitutions? That
The
side or
top.
this side? The top. Because the top has less substitution, that will be the what? The Ylide. So I am going to redraw the bottom, and I am going to put a double bond there. The other stuff is going to be the Ylide. I'm going to draw a double bond again. One side of that double bond is going to have the phosphorus. So you can understand, I keep writing pH. Okay, that's it. That's where this came from. It has a CH2 here. What does it have there? A CH2.
2, yeah.
Okay? All right. Where did this come from? How do you make this?
From the matter of the.
So,
The butanol
how many
with
carbons
lithium.
do you see here?
One.
One carbon. So, a halide with one carbon
Uh-huh.
and yes?
Yep.
That's the first thing that happens. And then your girlfriend Beauty.
Yeah.
So what does that give you? That gives you this.
Yep.
Yep. Oh gosh.
Okay, make that one.
So you will see it.
Guys, what mechanisms have we done for this chapter? Acetal, that's it?
Hydrate.
Just the hydrate.
But they're all the same, right?
Yeah.
Did we do anything with the nitrogen?
No.
Oh, let's do some of that. Did we do anything for the Wolff-Kishner?
No.
This is probably.
What's the driving force for the Wolff-Kishner?
It has to have
Sulfur.
No, NH2, NH2, right?
Nitrogen.
It had to have
It has to
hydrogen.
have a nitrogen
Nitrogen,
next to
nitrogen.
another nitrogen.
Nitrogen.
Why is that important? Because at the end, you will generate,
NH2 gas,
this
yeah.
N2 gas is super stable business, right?
Uh-huh.
Okay, where did this come from?
We split the double bond and you break the other one.
I break the double bond,
Yeah.
so like this.
With lightning.
Yeah, break it with lightning, huh? Okay, where am I going to put the carbonyl? On this side or on that side?
Right side.
Oh, yeah,
Which
the
one is
left
gonna
side.
be the Ylide?
The left side.
This is gonna be the Ylide.
Yeah, because it
Because
has
this
less
side of this
substituents.
carbon has less substitution, it has
Yeah.
hydrogen here. So that will be the Ylide. Yes or no? There it is, and I'm gonna redraw the other one now. The Ylide has a phosphorus here at the end, yes or no?
Yeah.
And the other one here, I draw it the same way, but with the oxygen. Is that better? Much
Yeah.
better. Okay, we beat that one to complete death. There's nothing left for us except the mechanism.
That's it? For now?
Yeah, I mean, if you wanted more, we could do more.
But the mechanism for that one was easy. It was short.
Huh?
It was so short.
Mechanism is easy,
Yeah.
right? For sure.
So short.
No, we're not doing the mechanism next time. Okay, so let's do the mechanism for this. Okay? So what now?
So that's the carbon.
This Ylide
Right.
will act like,
A nucleophile. It's gonna attack that carbon.
minus, and this is positive.
Uh-huh.
The double bond could do it by itself too. Okay, like you can have it from the double bond attacking bond. And we did this because we're talking about nucleophiles all the time in this chapter. So this is going to attack there. If you had this double bond like this here, this double bond could attack that.
Yeah.
Okay?
Uh-huh.
That's gonna happen to you very soon, okay? Next chapter. Not next chapter, the chapter after that. But for now, let's put this in the past. So, it attacks there and then what?
And then it's gonna,
Oh,
the
electrons
resonant,
go
yeah,
up.
up, uh-huh.
Very good. How do you know electrons go up? This
Because
carbon
it can't hold more than, you
cannot
got hold more,
make 5
yeah.
bonds.
Right.
So, here is electrons went up,
That's a negative, that oxygen.
CH3,
Uh-huh.
and then CH3, yes?
Yeah,
Bond to a carbon,
uh-huh,
yes or no? That is bond to a carbon.
yeah.
And what is on this carbon?
H,
It's a hydrogen and a hydrogen
and a P,
and a phosphorus.
right? The phenols.
A negative and
Yes. There is a negative on the oxygen. Any charges on this phosphorus?
Positive.
Positive on the phosphorus. So when it did the attack, it generated this positive. And it happens that this oxygen
is,
is in very close proximity to this phosphorus.
right.
And if it's not, it's okay because there is rotation on this single bond, yes? So this is going to go up. If it's down here, it's still gonna go up. And they're so close that this
It's gonna bond to the
is going
phosphorus.
to attack that phosphorus because that phosphorus is
Positive.
and what you are going to get is this thing that is a square, yes?
Uh-huh.
That's awesome. And this is going to have the two H's it had from before, and this has the CH3 and the CH3. This oxygen here. Yes or no?
Yep.
Check if you can follow that.
Yes.
Yes? Yes. And now what's going to happen next is this four-member ring is going to break. And
Break.
it's going to form what?
The oxygen double bonded to the phosphorus
So,
and the
here it
carbon-carbon
is.
double bond.
That is going to go there to make a double bond. So the two electrons from this bond went where? To make a double
Phosphorus.
bond with a phosphorus.
Phosphorus,
Yes?
yeah.
Now these two from here
Well, make a double bond with the carbon.
went to this to make a double bond between the carbon and the carbon. So what you have here now is carbon, double bond, the two hydrogens, and the oxygen is gone forever. That mechanism is easy, yes? You want this on the test.
But I like the way how you explain, you know, it could attack with the double bond too. Because it didn't say that in the book.
Didn't say that in the book?
No.
No, because the book is trying to do what we are trying to do in this chapter. Show you guys nucleophilic attack, nucleophilic attack, nucleophilic attack.
Okay.
When we have aldol and clays and condensation, so all those things, then there will be an attack with a double bond.
Yeah, I'm glad you showed that.
But even that, I'm going to split the double bond into positive and negative, so you understand where the electrons come from.
Okay.
So basically, these things are used, the ylides are used to make an alkanes. That's what it means.
Alkenes, yeah.
Oh.
I mean, their primary purpose is to make a carbon-carbon bond. That's the importance of it.
Professor, on the last day we lost the oxygen and the phosphorus, and now we have this double one.
No, we did not lost the oxygen on the, you mean, okay. Yeah, you and Gouch are friends.
I'm saying
No, but I agree. Okay, I did not draw it, okay? Not good from my part. This does form a double bond here, that's that double bond and whatever, okay?
Thank you. I'm confusing this nine way.
Yeah, I know. But if you know that one, how much credit I give you on the test? 0. You get 0 points. Oh, I drew triphenylphosphine, I don't care. Okay. We are going to do, we're gonna do one last one, okay? We're gonna do the Baeyer-Villiger, is that what it's called?
Adolf Bayer or something, that's his name, right?
Oxidation.
I don't even know how to spell it. It's with an E or with an I?
I think it's with an E.
Like this? Whatever, guys, it's not English 1101. Okay, and this is what happens. You have because this is aldehyde chapter, and you treat this with peroxy acid. So this is going to look like this. This is like that, written like this in the book. But this is called peroxy because you have here, this is like MCPBA. You ever heard of MCPBA before?
Yes. It makes it a very
Yes. MCPBA, okay? This is a peroxide, yes? And it looks like a carboxylic acid, so they call it a peroxy acid. Whatever, it could be MCPBA, it could be something else, I didn't even tell you what it was. But what you get from here is
Oh, wait. Oh, yeah.
What did the Baeyer-Villiger do?
Oxidize it.
Yeah, it did. It put an oxygen somewhere. It put an oxygen between the carbonyl and an R group. It chooses to put the oxygen in between, okay? If you have a choice, it will put it in between, let's say this is what we have. Okay, this happens because of a rearrangement. Write it down. Happens because of a rearrangement. In which the rearrangement occurs like this. It is best
Oh,
for
yeah,
hydrogen
that's
to
right.
rearrange, followed by something that is tertiary,
Secondary.
secondary, blah, blah, blah. Okay, phenol, primary,
Yeah,
methyl.
secondary phenol. Yeah. Okay.
Okay. So let's say we had, let's say we had something like, huh?
Never mind, I got it from my.
Good for you.
One.
Okay. Now, the oxygen is going to be introduced to one side of that carbonyl or to the other side, yes? What side is it going to go to? Is it going to go to that side, or is it going to go in between these two? Either those two or these two. Where is it going to go?
On the right.
Left side.
It is going to go to the side either methyl or
Oh, tertiary.
tertiary.
Oh, hydrogen.
This here
Yeah.
happens to be secondary, yes?
Yeah.
Better than primary.
Primary.
So the oxygen will go to this side.
That's right. That's right. See, but then that rule you was right. That's important. That rule right there. Yeah, that's important.
I don't get it.
Don't worry. We're not the only one.
It wasn't me this time, Professor.
What are you trying to grab? Trying to grab something? What do you mean you don't get it? You don't get what? Yeah. Look, there is a carbon R bond, yes? Yeah, carbon R. The oxygen will be in between the carbon and the R, yes? But here, it was the same here on both sides, yes? But here, you can put it between this or between these two. So where do you put the oxygen? Do you put the oxygen between this carbon and this carbon? Or do you put it between this carbon and this carbon? The rule says, look here, that's what the rule says. And if there is a hydrogen, it is a hydrogen that will migrate. Then followed by tertiary, then followed by secondary, then followed by phenol, primary, blah, blah, blah. It's a normal thing. So where are you going to put it? Here, this carbon is secondary. Okay, so the oxygen will go to that secondary. This would have been primary. Actually, this is not primary. This
No
is
problem.
Guys, yes or no? What? You want the mechanism for the Bayer next class?
You're right.
You don't want you want to get your money's worth in this class. You want to learn as much as you can, right? Okay, guys. See you in heaven if I die.
Pedro Garcia signing off.